Hi, thanks for coming out to listen to me. My name is Abhinav, and I'm the CTO at Ordinatim. We're a startup, as John mentioned, and we are on a mission to create self-driving companies. And with that in mind, data engineering is our first port of call. That's the first challenge that needs to be solved, and this talk is about why that's the case. So I'll go through 5 main sections. First of all, just to establish some definitions so that we're all talking about the same thing. What businesses want from data science. Second, where data professionals currently actually live, the world we inhabit today. The gap between these two worlds, and that's not going to be a surprise to most of you in this room. The bridge that crosses the divide, that brings us together, and then some examples of how it can be done. So what do businesses want from data science? Well, the standard agreed definition is that we want actionable insights. But what are these insights that businesses keep wanting data scientists to provide? And in order to understand that, we should understand what a business really is. A business is essentially a function that converts resources to revenue through some intermediate services that it provides to customers. So the customers provide the revenue back. And again, this is the definition we just establishing the ground rules, right? So what are these insights that we can provide about these various aspects of business? When it comes to revenue, we want to maximize the revenue and long-term revenue. We want repeat customers. We want to make sure that we are charging them the max we can charge them so that they remain repeat customers. We also don't want customers to leave because we're charging too high. So it's about finding the right price point, right? And in order to get these customers, we obviously want effective marketing. We want to speak to the right audience. We want to figure out if we are speaking to the right audience, what are the other fora we need to be exploring, and are we creating our message in the specific way that's pertinent to that audience. And all of this is not possible unless we have the right operations, because really the operations are the engine behind all of the things that a business does. And when it comes to operations, we need to understand if we have any bottlenecks in our system, because any bottlenecks are wasted resources. So where do bottlenecks arise from? Bottlenecks arise when we do not have proper resources. We need to understand what the right amount of resourcing is, because too little resourcing means someone is waiting for something to appear and fix a gap. And too many resources are just waiting on a shelf doing nothing and a waste of money, right? So we need the right resourcing, and we get these resources from vendors. And when it comes to vendors, we need to find the right criteria also to select the vendors, not just selecting the right vendors, but selecting the right criteria. If you've seen this movie, and by the way, if you haven't seen this movie, please go watch it this weekend. It's the movie that made data science sexy, right? Because before this, if you remember, people used to select baseball players on various criteria that made no sense, including how hot the girlfriend was, because apparently that was a good indicator of how good a baseball player someone is. And so this movie really showed how data science changed the world of baseball, and that's something we want to do to the business world as well, right? So that's the business world. Where do data engineers live? They live in a world of atrocious data quality, and frankly, we have all seen it. I've seen price columns with strings in them and strings which made no sense to be in a price column, and then you go, what do I mean from this, right? I've seen GPS data where I was supposed to be somewhere, but then it landed in the middle of the Atlantic Ocean, and I'm 15,000 kilometers away, and I'm going, what do I do with these rows? And so on and so forth. I mean, we do this, and we experience this every day. We live in a world of broken change management processes. Often not quite as stark as this gentleman, but we've seen deleted columns, we've seen added columns that people forgot to inform, we've seen added tables, new databases even, no downstream communication, things just change, pipelines break, hey, figure it out. It's Friday night, right? And then we live in a world of quirky vendor-specific APIs. So by the way, I just wrote some mock code. And as I was writing this code, I realized that there's this interesting little quirk that showed up in the mock example that I wrote. I was just, like I said, I was mocking up some code. And then I realized that my remaining spots, which was supposed to be an integer, became float. If anyone's familiar with the ins and outs of Spark, anyone want to guess what this might be about? No, I was subtracting two strings. It didn't throw an error. It just converted it to a float. I'd forgotten to apply the schema to the data frame. So these kind of quirky APIs and quirky things of what decimal precision you've got, they all change from system to system. And as data engineers, we are supposed to be across all of them. And this whole field, as every single other presenter has shown on some slide, has blown up with about 250 plus tools. So how do you get across all of them, right? And to understand this problem and to solve it, we need to understand first, where does this gap arise? The simple answer to all of that is the subset of people who have domain knowledge and the subset of people intersected with the subset of people who can code doesn't have many takers. And that's been a problem in our industry for the last 50 years. Because if you go back to where we all started, in the beginning, people who used to write code were scientists and mathematicians who were automating their own work by writing code. And at some point, it became a profession. And then we brought in people from other fields who were specialist software engineers. And when this problem was created in that space, domain knowledge was forgotten. Or actually, not entirely the case, because we've been trying to get this domain knowledge across in various ways. We've got documentation, we've got code reviews, we've got processes, and Agile and Scrum and Waterfall. But that doesn't fix the real problem, that we've got people who do not have domain knowledge coding and people who have domain knowledge not coding. So we've really inherited this gap right from the basis of where software engineering became a profession. And we have seen the cost of this methodology, or the lack of it, whichever way you want to put it, various times, over and over again. So some of us might be old enough to remember when this happened in '99, when NASA lost the Mars Climate Orbiter because of wrong units. The system expected metric because a scientist programmed it, and then the person sending the commands was used to English units or imperial units, whichever we want to call them, and was sending feet pound. And so the system got the wrong data, made the wrong calculations, promptly crashed and burned. A few $100 million were lost in the project, I believe, something of that order. And a couple of years ago, Skyscanner came down. 2 characters in a YAML file. What was the problem? The 2 characters basically brought down their entire Kubernetes cluster. So the normal graph and the normal traffic on those days of the week is the line or the lines going above. And then that particular day, for 4 hours, no traffic, no revenue, bad customer responses. You know what happens when that happens, right? And that's why I kind of think that YAML, when it's not being checked, should not be written. Like, we should always have checkers that are testing the YAML content. And I have some personal experience, nothing as bad as the examples I've cited, but I'll own up. I almost crashed a self-driving car once. Thanks to this bug, I was adding velocity to acceleration, and the car was speeding up way faster than it should have. And thankfully, nothing happened. We caught it before anything could happen. But the reason it came about was because I was adding 2 floating point numbers, which is perfectly fine as far as the compiler is concerned, right? So we looked into why this happened, and the code reviewer said, well, actually, I didn't expect you to make such a mistake. And that's the point. As long as we have human systems, we'll have human failings in the systems. No process can fix it. No code review, no Git flow, none of that can fix this, as long as we do not have systems that can actually solve this problem. So how do we bridge this gap? And almost as soon as the 2 fields separated, or rather I should say the 2 fields were created, we've been trying to solve this problem. We've been trying to solve this problem now for 50 years. We call this by various names. We call it semantic layer, Knowledge graphs. Data catalog is obviously the modern term for it. We used to call it ontology in some ways. But none of these are able to fix the gap because at the very heart, you still have this problem. Your semantic aware systems are not the ones the developer use. They are used for documentation or they're used for post-analysis. They're not used in the flow. In order to fix the problem, we have to try and realize the truth. There is no integer in the real world. Integer is an abstraction we created so that we could count objects. In the real world, there's not just one type of number. There are 4 types of numbers. Nominal numbers, such as identifiers, enumerations, etc., are used for identifying things. These can only be these can only be equal or not equal. Those are the only operations we should be able to perform. But there is no way currently of telling the compiler this information. Ordinal numbers can be compared with each other. So these are ratings, rankings, what have you, version numbers. Interval numbers can be added and divided, added and subtracted, but not multiplied and divided. And ratio numbers can be multiplied and divided, and exponential, and so on and so forth. But there is no compiler available today that can do this. There's no checking that can be possible as long as the compiler doesn't understand this. So what we really need are systems that have your back. How do we create such a system? We have tried various languages, and I think the consensus is the Python is one. Even Microsoft is now putting it in Excel or what have you. So, how do we verify business logic using the system? First of all, we should ban using base types. No integers, no floats, no strings. Use semantic types that are created for the business domain. So in this example, I'm creating email ID, which is of a string type. And when I'm creating it, I'm specifying the pattern. And any string that doesn't match this pattern obviously fails, which means that my compiler now knows how to create an email ID from a string and can inject this code where it needs to be injected. Because remember, a great feature of compilers is if there's a one-way function from a type to a type B, the compiler can inject it automatically without any user input. We can do the same thing, obviously, for numeric types. You can create length, as this example, and give it all the units. The advantage, again, of all of this is the compiler can be smart enough to actually create the parser from this information. You can give it the units, always store the data in the base unit. And that will make sure that you do not have a units problem that NASA had and causes a crash in the rover. And then you'll be safe to create these units from various types and to various types. So you can express them however you want them. You can ingest them how you want them. You can ingest them from any of these units, but they'll always be stored in the semantic type of your system. And then you can use these to create context types. So similarly to before, we can create passport ID, and then we can use the passport ID for human. Similarly for business, we can create the avian. Now, if you notice down below, in the founded by field, there's an ID type. And the compiler is automatically generating that for every kind of node. So there's a whole lot of code that a compiler can generate behind the scenes, including the counts, IDs, so on and so forth. So if you do a length operation on an array, for example, you should not get back an int. Again, that would break semantic completion. So the system can automatically figure out when a collection of a particular kind of object is queried for its length, that it should give the count type specific to that object, which means you cannot add people and companies together unless, of course, they're derived from the same base type. And this has applications in data quality and contracts, because now you can assert as normal programming to create your contracts. The compiler behind the scenes can generate the code needed to do the checking, informing people, so on and so forth. So what is the point of all of this is that once we've got these semantic types, we can build complex logic using these types. There's no need to build logic using the types we do today. And the compiler obviously can check all of this. When it checks all of this, it can actually make sure that the logic is sound. And the operations permitted are actually in accordance with the business logic. Right. Compilers have been doing this for 60 years, so that's not really rocket science right now. The other advantage of doing things this way is what compilers have also been doing for 6 years, which is processing your DAG. And in the data science world, or data engineering world, I should say, we call this lineage tracking. But really, lineage tracking is just your DAG. And compilers have been checking unused variables and the user variables for a long time. You can just reuse that functionality as is and get your DAG and sequence your operations, which means you can generate your workflows from your code without having to instrument all the workflows yourself. So when you do that, you get the added bonus of getting the workflow sequencing and also the parallelism, because if you notice here, from the requirements, you can do the, I hope you can read the code right up at the back. From the requirements, you can do the test design and the product design in parallel. There are two arrows with no common dependencies, which means your compiler is telling you these two operations can go in parallel, and in your business, you can really use that logic to figure out what business operations can be parallelized. So the advantage of the metadata is both ways. You get your tracking and your parallelism all in one. And did you notice, by the way, that when I specify the length, there was no data in this whole thing. This is all just pure metadata. So this can come from your product manager or your project manager right up front. There's no need for a human to write this. You can, in fact, have a UI provide this information, which means that your entire type definition can actually be used across the system in any system that your database can talk to and can be checked anywhere down the track. So if a change is made, you can enforce logic that only supersets of a particular type can be, a data can be changed to only its superset, which means it will not break. If a change is being made where you're changing the data to a subset, you can now go check the data downstream at the point of making the change, before it even hits your code, to make sure that you will not be impacting a downstream system. And when this happens, essentially data science and product management will start to look extremely similar, because really, who are the people who are looking for those insights from your business? These are people managing your projects, and these are people managing your products. So the two fields of data science and product management will start to converge, and data engineering and software engineering will reunite as one. In that world, data science will not any longer be about actionable insights. Data science will be about insightful actions. That's my talk. Thank you.